Hi, we are from Group 4. We want to present to you about the Vision Assignment 2. So here, as you can see here, for the first one, we use the CNN module so that we can run to identify which one the cane and the bottle. So for the first one, for the step one, we can see here, we need to connect to Google Drive first. After we connect to Google Drive, we can see at the below. So the free GPU on the Google Colab will pop up and we show the uh, table. We show the identified of the Tesla T4. Okay, next for the step two, we need to feed the dataset directory to import the OS. So for the first one, we want to import the image in the Google Colab. So we need to run the content Google Drive My Drive Vision assignment, so we can take from the file that we save. And then for the step number three, so we create the train and validation data directory. So in here we can see when we run the all the train and validation data for the image in the our file, so we can see the cane train length will show the 156. Meanwhile for the pit train is 30310, and same goes with the validation of the cane and also the pad. So for the next one, we construct the CNN model. So this is for the first method we use. So in construct the CNN model, we use the conventional 2D. So here we use a 3 conventional 2D and 3 max pooling 2D, and also the one flatten, and last but not least, we use the two dense of the layers. So when we run this CNN model, we can see the sequential of the model here. So the total parameter we show the 10 19 million 34 and 177, and same goes to the trainable parameters. So for the next step, we go to the step number 5, which is the pre-process the input data. So in the pre-process input data, we can classify the two model, which is the for the first one, we classify the image and also the cane. So in this classify, we target the size which are the 150, and also uh, same goes to the validation generator 150 also. So after we classify, we go to the next step, which is we import all the image, and we put the class name, which is the can on and the pad. So as you can see here, when we run, Google Collapse will pop up the image of the bottle and also the cane. So as you can see here, for the cane, we'll show the zero numbers, which is for the bottle, we show the 1.0. So after we plot the image and we start to the training the process. So here we use the epoch 10, so that the running can epoch in the 10 times. So after that, we plot the outcome from the training process. So we can see here there has a two graph, which is for the first one is the training, and the second one is the first one is the accuracy, and the second one is the loss. Meanwhile, for the loss validation and training, we show like this. So after that, we go to the see the first picture. So this picture we show we put the cane and the bottle beside each other. So when we train this bottle and cane, we can conclude that the Google Colab can read the percentage of the pad and also the percentage of the cane, which is both of them is a 100%. Okay, after that we change the position of the bottle, so that the bottle will go to the behind. So we can see here uh, the percentage of the bottle and the cane also we can get the 100%, so that the Google Colab will know which one is bottle and which one is the can. And the last but not least, which is we put the can is behind the bottle. So then the result we show also same, which is the bottle and the can will show the 100%. So this is for the CNN model. So next I will pass to the next presenter.
So for the second method we use is VGG16 model. The code for VGG16 is same as CNN model, but we need to change the code in step number 4, which is to construct the pre-trained model in VGG. the code is a little bit shorter than CNN model. Then when we run the code, it will shows the structure of the VGG model, which is their input and convolution pooling 2D, and there is no pattern in the structure. So after we run to the step number 5, it will shows the process input data for the VGG16. Then for step number 7, we generate the image for VGG16, and we can train the process. Here we set the epoch to 10. So the outcome of the VGG16 model, it will shows that the training process and validation loss is approximate to 1, and the losses is approximate to 0. So for the first picture, we train here, which it shows the image of the can and bottle is 100%. And for the second pictures, when the can is in front, and it can determine the can and bottle also 100%, and the last picture it also the same. The result is 100% for can and bottle. So I will pass to the next presenter.
Okay, for the third model, so we implement the Inception V3 to validate our data set. So the steps are also same as the CNN. And then we implement the Inception V3 model on the CNN architecture. We need to export all the libraries that need for training. So here is the libraries needed. So we use the weight ImageNet weight to train our data set. So the layers for the weight is shown in the screen. So there is multiples of convolutional 2D and activation, and a few max pooling. Okay. As you can see, the structure of the Inception V3. And then we merge the Inception with the CNN model, and we flatten it, and the final output is with total parameter 31 millions and total trainable parameter 9 million. And then we go to the pre-processing to process the training, and then we find out that there's a few images on 2 different classes. Then this step is used to identify the class name into cat and pet, when cat is can is 0.0 while the PET is 1.0. And then we start the training process to validate, and we set the batch size into 50 and 10 epoch. So the result of this training being plotted into 2 graphs, accuracy and loss. So the accuracy is at range 0.95 until 1, but the loss is at range 0. Until 2%. So for the prediction, we predict the two different classes in one image. So we found that the Inception V3 can identify the presence of the can and PET in 100%. Second, also it can identify the presence of the can and PET with 100% accuracy. The third image is also can identify the presence of can and PET in 100%. I think that's all from us. Thank you.